This is part 5 on our video on aqueous solutions. So we will finish the unit this morning. So I need for you to listen carefully. That's where we stop part 4 last time solving this problem. Let me quickly go over this. We have 10 ml of 0.25 molar barium chloride, and we have 10 ml of 0.35 molar sodium sulfate to produce barium sulfate and sodium chloride. You can multiply molarity times liter to give you moles, but you can also multiply molarity times milliliter to give you millimoles. Molarity times milliliter give you millimoles. If you don't want to convert your milliliter to liter, you can find millimoles. So those are the millimoles. 2.5 millimoles of barium chloride, 3.5 millimoles of sodium sulfate. We said the BCA means before, change, and after. We did not start with any barium sulfate, did not start with any sodium chloride. So whenever you start with two different amounts, remember one of them will always be a limiting reactant, and you should always use the limiting reactant to find the amount of product. So change, we will use 2.5 millimoles of barium chloride. Because it is 1-to-1 ratio, we will also use 2.5 millimoles of sodium sulfate to produce 2.5 millimoles of barium sulfate and twice that amount of sodium chloride. But since they asked me for barium sulfate, I did not really write the sodium chloride. So you have to always make sure you check the mole to mole ratio. Now, after 2.5 millimoles of barium chloride react, I won't have any barium chloride left. I will have 1.0 millimoles of sodium sulfate, and I will produce 2.5 millimoles of barium sulfate. The question is, how many grams of precipitate? How many grams of precipitate will form? I said last time you need to review your solubility rules, so you will know that the sodium chloride is soluble. It is not the precipitate. So barium sulfate is the precipitate. So all I have to do is I can take 2.5 millimoles of barium sulfate. If someone can find a molar mass of barium sulfate for me, please. Molar mass of barium sulfate. BaSO4, and I use conversion factor. I need grams. I will put my grams on top, and this is 1 millimoles. Of barium sulfate. Alright, so there is a problem here. I can change this to milligrams, right? I can change this to milligrams because I'm talking about millimoles. So can I have the molar mass of barium sulfate? 233.37. It is grams, but it is grams per mole. But it is also milligrams per millimoles. Yes, if I move both of them by 3 places to the left, it will give you the same thing. If it's confusing, do it in grams and moles. Okay, if 1 grams, let's say if 233 grams is the mass of 1 mole. 233 milligrams is the mass of 1 millimole. Is that okay? Alright, so what is the mass? What is the mass of barium sulfate? Can someone please multiply 2.5 by that milligrams? 583 425 milligrams, which is the same thing as how many grams? It is 0.5 grams. 0.5. Remember, you should always check your sig fig for every math problem. You need to check. This is how many sig fig? 3 sig fig. This is 2 sig fig. This is 3 sig fig. This is 2 sig fig. The answer is 0.58 grams of barium sulfate. You lose 1 point per questions for significant figure in the AP exam. Okay, now here is the challenging one. It says here, what are the concentration of all ions present in that solution? What is the concentration of each ion present? So let me make up some space here. Let's see how I can create some space to stay on the same page. Let's see, not the right shape. Let me undo quickly. The time is running. This is my undo. Let me go back and see. Okay, I don't want to get rid of the numbers, but it looks like that's what I will have to do. Let's see if I can erase few things that I don't need. The time is running. That's what happened with the video, and I don't have. Alright, they ask for what are the ions present in that solution. Let's see what are the ions. I have barium chloride. Do I still have barium? Okay, I don't have any more barium. I don't have any barium. So the concentration of my barium ion is 0 mole. Do I have chloride? Yes, I do have chloride, because all the chloride from the barium chloride, they are still in solution here, because sodium chloride is soluble. Sodium chloride is soluble. Next, how do I find the concentration of sodium ion? I write down Na1 plus equal the concentration. Why don't we use bracket for the concentration? The square bracket is the same thing as molarity. It is concentration. How many moles? Okay, I made a mistake. I erased the number of moles of barium chloride we had here. Was it 2.5? Okay, so it was 2.5 millimoles. So if I had 2.5 millimoles of barium chloride, for every 1 mole of barium chloride, I have 2 moles of fluoride ions. So I need to take the 2.5 millimoles multiply by 2, give me 5 millimoles of chloride. But they ask me for concentration, molarity. Okay, did we have 10 ml of barium chloride and we had 10 ml of sodium sulfate? Give you a total volume of 20 ml. So you should always remember to divide by the total volume, because that sodium ion is in that total volume. So it is 5 millimoles divided by 20 milliliter total solution, and it give me what? 1/4. 5 divided by 20 give you 1/4, which is 0.25. Okay, 0.25. What I just did, that mental math, that's what you will end up doing on your multiple choice a lot of those, because no calculator. So I know 5 is 1/4 of 20, and I know 1/4 is 0.25. So get used to this. Okay, now we are done with barium, we are done with chloride. How about sodium? I see all my sodium is left in solution because it is soluble. What was the millimole? I think it was 3.5 millimoles right here. 3.5, is that right? Is that 3.5 millimoles? Okay, 3.5 millimoles of my sodium, but sodium sulfate. I have 2 sodium ion for every one sodium sulfate. So it is time to give me 7 millimoles of sodium ion. We are not in sodium. This one I did here was chloride. Okay, this one was for the chloride. I wrote sodium, but it was chloride right here, Cl minus. This one is sodium ion. It is 7 millimole sodium ion, and I need to divide this also by the total volume, which is 20 milliliter. This is 7 divided by 20, give me 0.35. It is 0.35. It is molar. 0.35 molar of my sodium ion. So I did barium is 0, I did the chloride, I did the sodium. How about what happened with the sulfate? Remember, we have some leftover sulfate. Remember, we have some leftover sodium sulfate here. What was the after for the sodium sulfate? Was it 0.1? It's still there. It was 1. So we still have that sulfate in solution, the excess. Okay, so it is 1 millimole divided by the total volume, which is 20 milliliter. 1 millimole divided by 20. What is 1 divided by 20? 0.05 molar. So it is 0.05 molar of your sulfate in that solution. It is amazing that the time already flew, and I just finished the second part of one problem. So I will have to stay here. I cannot do any more. Even though I have plenty of other practice, I cannot solve all of those problems. So make sure you really learn how to solve this one, and you should be able with the others, and you have more practice in your packet. Study for your test and come ready. Multiple choice, no calculator. You will just have a periodic table to do the answer those 30 questions. So I hope you use your time wisely, and all your full responses should be done by today. Okay, so enjoy your day.